Hello and welcome to another video on my channel. In this video we are going to continue our discussion of functions, our function space. And if you recall, where we left off last time was that we were going to implement the string representation of the functions, not only the no-arg functions, for example for cosine, or the composition functions, but also when the return type is a function, an abstract class. Okay, because we said that in the function math we are going to create these utility classes and they are going to return functions. Okay, now I'm going to change the name of the function math to function space. Okay, that makes more sense to have a function space. Okay, so the question, how do we do that? So if we want to use this function space and all the return types here are functions, then we have to implement the toString method in the function. So in the abstract class function, I am going to override the toString method. So we go to source, override, implement, and from the object we create the toString. Now the caveat here is that we don't know when we're writing the code what is the actual type of the function, right? So what we are going to do, we are going to check. So if this, the function that we are right now trying to create a string representation, is instance of, for example, x dot, then what happens, basically return new x of, and then we pass composite func and then to a string. Okay, and then else if this is instance of, for example, sine, then what we are going to do, we are going to create a new sine, or I mean we could do that, or we could do a typecasting. So we can do both. Let's try this and then we can try typecasting. So if it's a sine, it's actually a sine, then we create a sine of composite func and then call the toString method. Else if this instance of cosine, then we create a cosine with the composite constructor and call the toString. And else we return not implemented yet. Okay, all right, let's go and see if this works. So we have the toString method for x, we have already implemented the toString method for sine, and we have the toString method for cosine. So x, cosine, sine function. So let's create a test class, test func string, and create a main function f1 equals so I'm going to import a static function space all everything, and we need to import function sine of x and system.out.println f1. all right, let's see what we get. Sine of x. Okay, and function f2 equals 3x, system.out, or maybe the shortcut is sysout, f2. Not implemented yet. Why? Because 3x is not a instance or not of type x, right? So we have to have something like a polynomial class also, polynomial type, which takes care of this kind of functions in general, or power function or something like that. But for example, if we write cosine of x and write it down, it writes cosine. Now what happens if we write the composition cosine of sine of x, f3? Because we have implemented the toString for both of these, this should actually work, but it doesn't. Why? Because let's go back to function. In the cosine and in the toString method, composite function toString and sine of x. So the reason is that sine of x, the return type is a function, right? It's not a sine object, it's a function object. That's why it's not able to. Or if we do a typecasting, it still doesn't work, so typecasting doesn't help here. So the question is, how do we overcome this problem? I guess there are a couple of ways to do this. One is in this utility class, instead of returning in the function space class, okay, instead of returning a function for sine, we just simply return sine. If for the cosine, we return a cosine object. Okay, there are still subclasses of sine, and for some reason this is still oh, okay. No, I was actually returning, this is my mistake, I was returning f2, should f3, cosine of sine. So one thing that we can do is in the utility class, the function space, for sine we return sine, for cosine return cosine. What happens if we change them back to function? The question is, does the composition, the string representation of the composition works? And the answer is yes, it still works. Okay, cosine of sine, function f4 is sine of cosine of x, and sys out f4 still works. Okay, now because of the diff of sine of cosines or sine of cosines, I believe even the diff should work. So f5 is f4 times diff, and then sys out f5. Let's see. Not implemented yet. The question is why? And the answer is this diff is returning a function, and it's the problem here now is that that function is the multiplication of two functions, and we didn't take care of that. So the question is, how do we take care of the multiplication? And that makes things complicated, right? So in order to take care of that, what we need to do, we need to create objects that take care of multiplication. So they are objects that contain the multiplication, and then implement the toString method for those. So here I'm going to create a class called multiplication, and then this multiplication basically takes two functions, okay, elements. So f1 and f2 are elementary functions, and then basically function f1 f2, this dot f1 equals f1, this dot f2 equals f2, and the multiplication also extends function, okay. And we are going to implement the get value, return f1 get value times f2 get value, okay. And then in the diff we return f1 dot diff times f2 plus f1 times f2 dot diff, okay. But then these two are also multiplications, so we have to have also a class for summation, for example. So for each operation we have to have summation, and those are basically also the functions that extend our based function. Now why are we doing this? Because then when we have a summation or multiplication, we already know how to do the toString method on those, right? Because in this abstract class we have to check the type of the object to see what kind of representation it should have, right? But if the multiplication of two functions and then the type is not defined, we don't have any unless we have a class that represents the multiplication, okay. So now let's go and basically what we are going to do is in the multiplication we are going to, and the same for summation, and then maybe let's also override the toString method here. So we are going to source here, and then let's override it from the construct. Okay. So if we have the multiplication of two functions, our basically our toString is just to have f1 dot toString plus times plus f2 dot toString, okay. And then what happens here is that in the function, for example, now if we have else if this instance of multiplication, return new, or maybe just let's do typecasting, multiplication this. So we do a typecasting and then try to implement the toString method on that. And also let's do the typecasting on these instead of creating new objects, we do a typecasting. So of type sine this, and then here of type cosine this, okay. Let's go here, make sure that these should still work. Sine, cosine, cosine of sine, sine of sine of cosine, and diff doesn't work here because diff includes the multiplication. And then what we want to do, basically we want to go and override the basically the multi here, subtract, multiply by a number, multiply by a function, multiply by a function, for example. So instead of doing this, what I'm going to do here, I'm going to return new multiplication. F1 is this, F2 is V. Okay? And we already know how the string representation of the multiplication looks like. So the same thing here. V times this. Okay? And so whenever we multiply two functions, an object of type multiplication is passed. So let's see if we function f6 is sine of x times sine of x. So times is define system.out.println f6 instance of multiplication. True. Okay, so f6 is an instance of multiplication, and let's see what we get in the toString method. Sine times sine. Now this works, okay, because in the function now we have a type of multiplication. Okay, now what we ignored at the moment is what happens if we pass in a number. So in the multiplication we have to also have another constructor, public multiplication, but then we have to have a function f1 and a number double v, for example. Then what happens, then this dot f1 should be f1, this dot f2 should be new fcv. Okay, and when we have multiplication we always want to put the number before the function. So we want to have 2f of x, for example. We don't want to have f of x times 2, for example. We write 2x or 2 sine of x. So in the toString method we make sure that f2 comes first. Basically if f2 instance of fc, then we want to return f2 then f1, else we just want to return f1 first. So sine works. Function f7 sine of x times 2 sys out f7, not implemented. The question is why? Because in the when we were doing operator overloading we didn't implement. Oh yes, so return new multiplication and function this, and v is v. Okay, and multiplication reverse takes the same thing. Okay, so in the test function, now let's see if sine times 2 works. Yes, 2 times sine of x. Okay, and now why is it that we get the f of, okay, so the reason that we get this is because in the toString method of fc, okay, so we should probably just yes, 2 sine of x. All right, and so yeah, this is the way. So for example, if I write now function f8 equals 3.1 times x, and then do sysout f8, the string should come out. Yes, so we really don't need to have a polynomial, for example. So 3x plus 2, we haven't implemented the summation yet, so we can in the next video I'm going to implement summation, and I hope you understand how we're implementing the string representation of our functions. And the way we're doing it is breaking down the object or operation hierarchy of functions into summation, multiplication, subtraction, and division. So we should have these. Instead of summation, let's rename it to addition. The reason we have to do this because otherwise if we have a function, if we multiply two functions, the result may not be an object of one of these elementary object types, elementary function types. Therefore, we don't know how to represent that. Okay, that's why we're implementing these 4 operations: division, multiplication, subtraction, and addition. But for these, now we know how to create the toString method, and a combination of these creates a full hierarchy of a string representation, which we are going to see in the next video. Thank you very much.